Bismillahirrahmanirrahim. Assalamu alaikum. So here is the project presentation of the Auditd rule writing for better threat detection on Linux devices. So before going into detail, let's talk about a quick introduction about this project. So this project is basically the final year project of the BS Computer Science degree from Information Technology University, and Sarwakar Ahmed is the supervisor of this project. This project is basically proposed by the eBricks company, and Sir Fahad Iqbal and Sir Rana Awais are giving the continuously mentorship on this project. So let's talk about the agenda of this presentation. In this presentation, we will talk about the Linux kernel auditing system and Auditd alternative for Windows, that what we use for the Windows auditing, and what are the suspicious activities and how Auditd help in detecting those suspicious activities. And by the analysis of the logs of the Auditd, we also get that the limitations of the Auditd, and we will also talk about that how we can conduct the real-time monitoring using elastic stack and beats. And on detecting the malicious activities, we can also generate the alerts. This is basically the roadmap is shared by the eBricks. This is the phase of our project which we have to follow over a year in order to completion of this project. So in which we have phase 1, procurement of machine, auditing familiarity, writing rules and searching logs management using syslog, expanding auditing coverage, detect and alert on suspicious activity, and in the end testing Oddity on the simulation, like simulated attacks. So let's start. Here are the tools and technologies that we used throughout the process of this project. So here it is, the Auditd, Debian, RHEL operating system, Strace, Elastic Stack, Beats, Grok filter, which is in the dev tool menu on the Kibana, and programming language like Python and Bash scripting and other stuffs like that. And in the first phase of this project, we have to do the procurement of machine, in which we have to learn about the Google Cloud platform, that how we can use it. We also create the Debian and RHEL operating system instances on the Google Cloud platform, and how we can connect to that instances using SSH protocol from the terminal on the Linux systems, and PuTTY software on the Windows machine. For this project, in which we have to do the analysis on the user activity, so it's very necessary for us to learn about the Linux user management, because since Linux is a multi-user operating system, and several people may be logged in and actively working on a given machine at the same time, security wise it's never a good idea to allow users to share the credential of the same account. In fact, best practice dictate that the use of as many users account as people needing access to the machine. At the same time, it is to be expected that 2 or more users may need to share access to a certain system's resources such as directories and files. So user and group management in Linux allow us to accomplish of this above of the objectives. In this user management, we learn about the add users, add groups, how to delete the user, and modify the user account and other stuff like that. So, and here are the screenshots of the Google Cloud platform, in which we see that we install the Debian and RHEL operating system, and we can access these instances using the external IP, which I hide in the screenshots. We also create the rules, create the firewalls rules to for the Elasticsearch, Kibana, and Logstash. So let's about the second phase, which in the phase of Oddity familiarity, we have to learn about how the Oddity service work, and go through the official manual page of the Oddity, and play around with the utilities of the like Auditd, AU report, and AU search. We will talk it about a bit later. So basically, Auditd is the user space component of the Linux auditing system, and the job of Auditd is to collect and write log files of audit to the disk as a background service, and it provide to track the security relevant information on our the system, and it generate log entries to record as much information about the events that are happening on our system as soon as possible. So we also have to learn about the alternative for auditing on the Windows. So basically for Windows there is the Windows security auditing, which is disabled by default, and we have to enable, and by enabling various auditing events categories we can implement we auditing policies is like what types of event that we are interested about, the object access, policy change, privilege use, and stuff like that. In the Windows we can apply audit policies to individual files and folders in our computer by setting the permissions type to record system successful access on the system and failures on over the system. So here is the complete architecture of the Oddity, in which we can see that Oddity is a user space component which is getting the events from the kernel space, and we have the AU disk. AU disk is basically the used for the transmission of logs to the remote system, and we can see that the AU report, which is a utility for producing summary from the audit records, and we can search in the logs using the AU search, which is a utility for searching the audit logs for events, and we can use advanced searching by using different flags with the AU search, different parameters with the AU search. And last thing as AU last, which is used to find the user who logged in last by parsing the audit records. So this is a complete architecture of the Auditd. Okay, the last thing that we missed at Auditctl, that is used to add the rules, remove rules, and to get the report of the status of the auditing system. So now move towards the third phase. After getting the complete familiarity with the Auditd module, we have to now write some rules and search on the logs that are generated against those rules. So in this phase, in the third phase, we write some rules and use the AU research to searching the required logs and AU report to get the report of the audit records. If we talk about the rule management for using the command line, for this we use the Auditctl to add the rules or remove the rules. But the Auditctl component, which is a component of Auditd, the rules that are written using the Auditctls are not persistent. When the system is boot up, the rules are not there. So in order to make the rules persistent, we use the configurations files and we add the rules in the audit.rules files that is in the directory of etc audit in the system. So basically we have the three types of Auditd rules, like control rules, file systems, and system call rules. Control rules are basically used for the behavior of the Auditd. Like in these rules we can set the buffer size and all of the stuff like that, and in the file system rules we specify that which files and directories we are going to monitor and what type of accesses that we want to monitor, read, write, or execute or attribute chain. In the system calls rules, we add the rules of the system call so that we can log the activities is on that system calls that are called by the specified programs. So here is the format of the rules that we can add by using the Auditctl. So in the first screenshot we can see that we are adding the rule, and minus w shows that we are putting the watch on the file, and minus b indicate the permissions. Permissions we can write the read, write, and execute an attribute, and we can give any rule a key name which provide us an easiness to search in the logs by using the key name, by using the label, in order to get the specific logs from the audit records. So in the second screenshot we have the format of the system called rule. So after adding the rule, the important thing that you have to note here, that after adding the rules in the audit.rules files or by using auditctl, you have to check that whether the rules are correct or not. You can use the organ rules double minus with the load flag that will show you that the status of the rules that you put in your files. And you can in the second screenshots of AU research and AU search and AU report, you can see that how can we get the information about the logs that we in the AU search. We can see that we are taking out the logs that is specifically for about the user login, in which we had the success as, and in the which we had the success no, it's mean that it's in which we have the failure in the access in the success, mean that there is a failure in the login attempt, and interpret show that that we can make them human readable. In the A report we get the summary of the audit record of the system, and we can also use the different timestamp in order to get the logs of the specified time. Now we have the fourth phase of which is the log management using syslog and Elasticstack. In this phase we learn about the syslog and the Elasticstack, and how can we transfer the audit logs to the syslog and from syslog to the Elasticstack. For Auditd logs to syslogs, we use the audit dispatcher, which is the Auditd utilities, and from syslog to Elasticstack we use the beats to get in order to conduct the real-time monitoring on the Elasticstack. After getting the logs on the Elasticstack and after getting the indexing of the logs, we can create the different visualization in order to get a good understanding of our logs. So basically syslog is by default is in the Linux, which is used to track and log the system events, and the logs of the events are exported to the specified files as in the var log directory. Like if we have the login logs, then they are transferred to the authorization.log file. So the syslogs export the logs of the specific related events to the specific files. So here we have the Elasticstack, in which we see that it's consists of four modules. Four modules. That first we have the beats, which is a lightweight data shipper. From beats we can transfer the machine from the logs of the machine into the elk stack of the server. Elk stack consists of log stash, Elasticsearch and Kibana. So logstash is basically collects the logs from the beats and then parts and store for the Elasticsearch, because the logs are in the form of raw data, so the structuring is necessary for understanding of the logs. So when the logs are structured, they are transferred to the Elasticsearch, and after getting the logs in the Elasticsearch, we can create the different visualization in order to get the good understanding of our logs. So here is the screenshots of the what type of visualization that we can create in the Kibana. So here we can see on the right top about the login attempts, at how much login attempts is failures and success, and on the left side we can see in the pie chart about what types of events that we are collecting in our system. is the second screenshot for the visualization, and we will we will talk about a bit more about this visualization in the demo slide. So after at this point we can create a whole system architecture picture in our mind. So we have this architecture in which we can see that we have the client machines, the different client machines with the Auditd module. So dispatcher is using to transfer the Auditd logs to the syslogs, and then syslogs transfer logs to the file beat on the end of the machine, and then file be transferred on the end of the machine logs to the elk server, where we have the log stash where we collect different logs and structure them and then transfer to the Elasticsearch, and then we on Kibana we create the visualization, and if we find any suspicious activity then we can create the email alerts. But we can make this architecture a bit simple because Auditd can without using the audit dispatcher we can take the Auditd logs directly by using the file beat. So here is the simple architecture that we make in this project, that we get the logs of the Oddity by specifying the files that we are interested in the file beat configuration. So file beat take the logs of the Oddity and then transfer to their log stash, and then the whole process remain the same. So now let's talk about the fifth phase, which is the expanding Oddity coverage. In this phase we spend a lot of time in order to understand what type of malicious activities that we are going to detect in our systems by using Oddity. So here we research about the advanced persistent threat like hidden wasp and study about it, and we also study about the CV 2017, and we also see the attacks like privilege escalation, reconnaissance, and understand the Auditd MITRE Attack frameworks and GTFO pin. We will go in the detail a bit later. We will also talk about the Auditd rules limitations and why we shift towards the Sigma rules. So in the expansion of the Auditd coverage, we learn about the hidden wasp, which is advanced persistent threat of the Linux machines, and we studied about this threat on the Enhancer, the Enhancer article, but we can't say that we can detect this malware using Oddity, but we can see that what type of file accessing that this malware probably do. So here we have not we haven't available the hidden wasp malware, but we have the scanner which detect the files that hidden wasp use in its attack. So the scanner is available on the GitHub page, and which you can see that there are a couple of libraries that are going to be detected by this scanner. So here we search about this, and we also see the Linux kernel exploit, which is used to set the set UID of the system or of the set UID of the files in order to get the shell to spawn the shell in order to escalate the privilege. So a bit later we will discuss that how we can detect this type of permission change in the Linux system. So here we have the picture of MITRE Attack framework, which is basically a comprehensive matrix of tactics and technique used by threat hunters and red teamers to better classify, attack, and assesses an organization risk. So basically in this picture I list down only the attacks that we can detect using the Oddity. So this is available on the Audit Attack Be Fuzzy on GitHub page. Now we have the GTFO binaries. This is a list of the binaries that can be exploited by the attacker to bypass local security restrictions. So basically all these types of attacks, we wrote the rules of Auditd, and we detecting those rules in, and we detecting those logs in the Elasticsearch. So basically I'm telling about these attacks that we covered in our project. So here is the Liaison script, which is also available on the GitHub page. It is used to retrieve the password from the databases of your browser and your Wi-Fi and your system passwords that are saved in your systems, and it will show them. As in the screenshot. So these types of malicious activities that we are going to detect using Auditd. So there is a limitations in the Auditd rules that we can detect the files access that are critical for our system, but there is some limitation in Auditd rules that we cannot provide. It can provide the flexibility to write the rules on a specific command with its parameter. Let's suppose in this we have the command like sudo nano etc shadow. So we can detect, if we write a rule on the shadow file, we can detect that this file is accessed, but we can specify the rules for this specific commands, that if we want to write the rule that if the commands executed like nano with parameter etc shadow, then we can't write the rule on the commands. So that's why we go towards the Sigma rules, which I talk about a bit later. So existing Auditd rule standards like stick caps and default rules have the limitation in detecting suspicious activities, and we will talk about later about why I'm claiming this, that why the standards are not good in detecting suspicious activities. So Auditd attack rules for MITRE Attack is also blind to some attacks. So basically this was our analysis that we conduct, that there are some events, there are some activities that are not logged by the MITRE Attack framework. MITRE Attack framework rules that are defined by this BFuzzy official page, on the BFuzzy official page. So here we come towards the Sigma rules, that is an open source standard for rules that allow you to describe searches on logs data in generic form. The rules can be converted easily into the Elasticsearch query so that we can detect the suspicious activities is in the audit log. So as we can't write the Auditd rule on a specific command, but we can see in the previous slide that we have the log of the command with its parameter. So what we do, we transfer these logs to the Elasticsearch server, and then we can detect them using the Sigma rules and then converting the Elasticsearch queries. So we wrote the Sigma rules for MITRE Attack, Liaison script, and CVE and GTFO binaries. So in the next phase, I will show you that how we detect and alert all these suspicious activities. So there we have the Elasticsearch queries in which we have to in the query we specify the specific event, and when we apply, then we get the result of the specific query in the logs. So when we detect those, when we get the result of that suspicious activity, then we generate the alerts using the Elast alerts. So here is the alerts that are generated by the Elast alerts. So basically it's about a demo of the alerts. So now we have the last phase, which is the testing Auditd with the simulation. So here we finalize all the Auditd environment in which we have the Auditd, FileBeat, Elastic Stack, and all the setups are done completely. So we learn about the attack simulation in the as it is mentioned in the paper of Sense, in which it mentions that the simulation of the OS level reconnaissance, application level reconnaissance, application level layer attack, SQLi, OS command injection, and SSH brute force, local privilege escalation, rootkit installation. As I talked about previously, that caps and sticks and default rules are completely are blind to some types of attacks, attacks. So in this paper it mentions that caps, sticks, and default rules are completely blind in the application level reconnaissance, application layer attack like SQLi and OS command injection. But these standards give little bit help in detecting in OS level reconnaissance, local privilege escalation, and good in the SSH brute force attack, but little bit in rootkit installation. So this all over, this is all the project. So now let's look at the demo that what we developed so far. So here is the demo of the project video. In this we will see that service Auditd current status. So Auditd is running. We can see the rules in the audit.rules files using auditctl, so it shows all the rule status, and we can check whether the rules in the files are correct. We can use them by loading the rules. So all the rules are correct, there is no any error status. So now the based on the rules, the logs are generated and are recorded in the directory of the audit.logs, and these logs are then sent by the file bits to the log stash. So these raw data logs are then structured into the by the log stash. As we define the filter in the log stash, we just see here it is in the etc log stash and configuration, and this is and there you can see that it is taking the logs from the port 5044, which is from where the file bit is sending the logs, and after getting the input, the logs are then structured in by passing from this filter, and then the logs, structured logs, are then passed to the Elasticsearch on the server. So here is the Elasticsearch running, and this is the Kibana dashboard, and you can see that the logs are in the indexed form. In a good way we can conduct the analysis. So here is the fields. So logs are parsed based on these fields that we defined in the log stash filter, and you can see that we also create the different visualization. As you can see, this cybermeans is the system username, and it's the user IDs on the systems, and the current status of the successful logins, failed, and success. So this is the all the audit events that we are interested, and the system call status of failures and the success. And here you can see all the file access on the system, and here is a top executed command in the system. And you can also see here that we talk in this presentation that as CVE, as we talk about the CVE, that spawn a shell and execute shell by the root privileges. So we have to detect that. We can detect as you can see that the chmod command which is used to modify the permission, permissions of the file. So you can see that this command is run by the root privileges as SUID is 0, and this command is run by the AUID of 1000, which is the normal user, not the root user. So you can see that this type of suspicious activity you can detect here. So if we go here and see that in this scenario, that if we attempt wrong passwords, and then if we use correct password and you get login, so we can see that status here in this. So you refresh, So here you can see that this is now updated that 29 failed events and 27 are the success. So this is all working good. Now here we have the MITRE Attack framework dashboard, where that we discuss in the presentation that we created the rules to detect the MITRE attack that can be detected by Auditd. This is all of the status that about system suspicious system calls for the privilege escalation, for file deletion. We create separate visualization so that we can make a contextual analysis, local job scheduling events, spam related events, reconnaissance related events, and persistence related events, remote events, pseudo events, and executed valid user account executed commands that has the access to only has the root. So these are all the status of the malicious activities on the system. So now what we do next, we have the elastic stack. So here we repeat the process from where we left. So here we pass the 3 incorrect password, and the last alert generated the alert and sent to the email. So we can check the email, and here we can see that we get the email from the last alert with the subject of quick demo, but it shows that at least 3 events occurred at this time, and you can see that what types of events that are generated in the last alert. So you can see that this sent a complete status of that message that user authentication is failed. So number of hits are 5 and number of matches are 1. So you can see that how we can be alerted on the malicious activity. So the most important thing to note here is that for this you must have to enable the less secure app access on the Windows in order to generating the alerts. So so this is the whole process of our project. So now, after getting the complete walkthrough of the project, we get the conclusion that how Auditd helps us in the threat detection, and what are the Auditd rules limitations, so that we use with Auditd rules the Sigma rules that helps in detecting the suspicious activities on the Elasticsearch, and what type of attack that we can detect using Auditd, and on which attacks the Auditd is completely blind, like application level attack, like SQLI, etc., and on what attack it's passed, and on which attacks it gives some type of evidence. And we also conduct the centralized real-time monitoring on the Elastic Stack, and create the visualization, on suspicious activities the alerts are generated, so we can take the quick action against those alerts. So Auditd is not enough for the endpoint security, because audit log does not contains the all information of the system, because the network information is also missed by the audit logs, as it is in the Apache logs, or there are different logs files that are important for us, that access logs, auth.log that contains the critical information. So audit.log is not enough for the endpoint security. So for the future work, there is a limitation in Auditd, as if the process performs a suspicious activity, as we see that for a single event there is a lot of different logs are generated for the single event. So we can't map different events on on a process that generate those events. So here writing rules only based on the PID wouldn't be possible. So we can still write one in a more developed scheme by creating a database mapping for PID process name and then comparing the corresponding process name of PID from this event with whitelisted process name. So WUSA SIEM is also an open source for threat detection platform and does have implementation. So this is our future work. So in the end,